My name is Caio Neuhaus. I am a solutions technology consultant at SUSE. I work with implementation, design, and optimizing SUSE environments. And this was one great project that I worked. By my side is Leon. Leon, you want to introduce yourself?
Hi everyone. I guess, okay. Thank you for joining here. So I'm Leon Paiva. I'm a DevSecOps specialist, so I worked with the Brazilian Public Ministry for almost 10 years. And there I led the DevSecOps teams to multiple migrations, virtual machines to containers, containers to Kubernetes. And now we are moving to the cloud and hybrid environments for a large organization for the whole country. So we serve over the 27 states with 9,000 employees and 2,000 IT professionals. And we provide this architecture, and changing all this throughout the whole organization is a big project serving multiple organizations, not only the Brazilian Public Ministry. And we are going to showcase. I'll give the word to Caio so he can continue with the presentation.
All right, so the topic of today is how the Federal Public Ministry of Brazil enhanced its migration from RKE1 to RKE2 with SUSE storage. The agenda for today is split in 6 parts. So we're going to start with a basic introduction to RKE2 and SUSE storage, so you get familiar with those products. Then we move to the key differences between RKE1 and RKE2, the customer environment overview, the challenges that we had in migration processes, the benefits of using SUSE storage, and finally, the results achieved in this migration process. So starting with what is RKE2 and SUSE storage. RKE2 is a fully conformant Kubernetes distribution focused on security. It provides you default configurations to pass in the SUSE Kubernetes benchmark. For those who don't know, SUSE stands for Center of Internet Security, and it contains all the standards that you need to pass and maintain secure your Kubernetes cluster. So RKE2 already does that for you by default, so you don't have to worry in performing those configurations manually. In addition to that, RKE2 also encrypts at rest your etcd database. So your secrets, for example, that you deploy in Kubernetes are encrypted by default. Also, RKE2 provides you an easy installation. So throughout the installation script, you download the binary, install it in your operational system, and you have your Kubernetes cluster ready to run. Basically because he deploys all those components here in a single binary using Helm controllers. So kubeproxy, the CNI, core DNS, metric server, and ingress is already built in. Of course, you can change that. For example, you can use different CNIs. You can use, instead of kubeproxy, you can configure eBPF using Cilium if you want to. This is the basic architecture of RKE2. So here on the left, you can see RKE supervisor that interacts with kubelet, and kubelet deploys the main components of your Kubernetes cluster as static pods. So etcd, API server, controller manager, cloud controller manager, and the scheduler will be deployed as static pods. And this is where the RKE2 server node, where you will run your main components. And here on the right is where you run your application, so the RKE2 agent node. So you have the RKE supervisor, the kubelet, and you have your application and also the components that I mentioned to you. And what is SUSE storage? So SUSE storage is also known as Longhorn. Longhorn is the community version. SUSE storage is the enterprise version supported by SUSE. Both are open source. It's a lightweight, reliable, and powerful distributed block storage system for Kubernetes. An interesting feature of Longhorn SUSE storage is that it is hardware agnostic. So you can run both on-premise environments and also on cloud environments. So this was really interesting for the Federal Public Ministry of Brazil, because now they are starting their journey with cloud environments, so they can run Longhorn workloads both on premises and on cloud environments. Longhorn provides you efficient storage management. So Longhorn gives you a graphical user interface where you can see the full life cycle of your volumes. This is great, especially during the migration process. You can perform routines, daily routines, like snapshots, backups of your volumes. Longhorn also provides you a strong data reliability. So in this image here, you can see 3 pods. Every pod has an engine, a Longhorn engine, and that engine controls the state of your replicas. So the replicas is where the volume will be stored. So in this example here, as you can see, one replica goes to the node 1, and another replica goes to the node 2. So that way, you guarantee the high availability of your workloads, because in case node 1 goes down, you will still have the additional replica running in node 2. And after you rebuild the node 1 and node 1 gets back to the cluster, the replica is rebuilded automatically. So this is also a nice feature of Longhorn. In addition to that, Longhorn provides you dynamic provisioning. So it provides a storage class, so you don't have to worry about creating persistent volume claims, persistent volumes manually. You can also set up recurring jobs on Longhorn and point it out those recurring jobs for be using in specific storage classes. And because all of that, Longhorn provides you a simplified storage solution. So you have a bigger picture of the full life cycle of the activities and the observability of your volumes. If you want, you can expose those metrics using Prometheus and Grafana using a centralized tool to view your persistent volumes and so on. And Longhorn is also easy to install, so you can install it throughout Rancher. One of the things that we did in the Federal Public Ministry was configuring also an ingress resource because in case Rancher goes down, it doesn't affect you accessing the Longhorn graphical user interface. So this is the graphical user interface. As you can see here in the left, you can see how many volumes you have, the state of these volumes, if they are healthy, degraded. Degraded means if one of the replicas is not working properly, so you can see this whole view of the life cycle of your volume. You can see the event log, what's going on when you are creating a volume and so on. You can see the storage schedule, how much is being scheduled, reserved. You can see the nodes, if the nodes are running okay, if they are unscheduled, which means that they might have some issue. This is the node, and here in the bottom, the volume page. So in the node, you can see if the node is scheduled, how many replicas you have, how much is being used. The volume, you can see if the volume is in the detached state, which means it's not being used right now in this example. The actual size, it's the size of the volume and also the size of the snapshots that you have. And in here is where you create recurring jobs. So we've done that in the Federal Public Ministry of Brazil because that way you can schedule routines for your snapshots, for your backups. You can set it up. The retention, it's important to mention that the snapshots are stored in the node itself, in the cluster itself. So you need to make sure that you have available disks for that. And the backups, in opposite, it's stored in an external location, okay? So the concurrency means that these jobs can run in parallel with additional jobs. The cron job is the schedule that you can define. The groups and labels is where you can configure, for example, if you have critical applications, you can set it up specific recurring jobs for those critical applications and do the same for non-critical applications. Here in the bottom is some of configurations that you can make in Longhorn. So the storage class name, you can change the storage class name. You can create multiple storage classes. In the Federal Public Ministry of Brazil, we configured a storage class using node disk tags, pointed out a specific storage class for disks with more performance. So we have done that. The default replica count you can change as well. I would recommend maintaining at least 2 replicas to guarantee the high availability that I mentioned to you. And what were the main differences between RKE1 and RKE2 that were the reason that the Federal Public Ministry of Brazil decided to move from RKE1 to RKE2? So the first one was the container runtime. So RKE2 uses container D, which is faster than Docker in our tests. The second one is the main components. So RKE1 deploys the main components, which are API server, etcd, scheduler, and so on, as using Docker. And RKE2 uses kubelet and deploys as static pods those components. The third reason was about security. So with RKE2, you can pass in the majority of the Cisco Kubernetes benchmark easily without manual intervention. And RKE1, you already can, you can do that, but you have to perform those activities manually. And about the supportability as well, RKE2 is the standard for our SUSE products, and RKE1 will end his life cycle in the next year. In addition to all these 4 reasons, another reason was when you are updating your Kubernetes cluster, you have to make sure to update Docker in RKE1 and make sure that the versions are compatible, Docker, Kubernetes, and also Rancher. So in RKE2, since container D is already built in, you don't have to worry about that. So you don't have to worry about deploying Docker, maintaining Docker, and so on. All right, so after this basic introduction about the products, I will hand over to Leon. He will explain more about the Federal Public Ministry of Brazil architecture.
Hey everyone. So before I dive into a little deeper on our architecture and what we did and how we did it, let me just give a quick overview of what is the Brazilian Public Ministry and what we do over there. So the Brazilian Public Ministry is an individual, independent agency and federal agency that oversees the whole law enforcement and interacts with it to enforce actions against organized crime, child abuse, human rights, and corruption as well. So it oversees all the legal suits and lawsuits over the whole country, and we see over like 3 million lawsuits every year, and that's happening over our organization for all the states. So we provide these services and applications for the whole country. It's a large operation that we do there. So let me go over our architecture. So we do have a very diverse set of applications, and to support that, we actually have a multiple set of clusters to have high availability and also resiliency throughout our organization in the whole country, and that gives us a better management for our services as well. Let me just go over the first set of our architecture here, and yes, oh sorry, yes. So in the top we actually have a central control Rancher cluster, and we have that with high availability as well to manage all the downstream clusters that we have on our organizations for development, production, and staging environment. And throughout that, we manage our firewall rules, security rules, and we also have a high visibility and observability for our applications as well. We do have high availability for each of those ranchers, so if anything goes wrong, we still have visibility of all of our clusters. And we also have a control server that we manage the access for like automations, and also our team manages to have a centralized control server to simplify our security measures as well. Through all that, we deployed visibility and observability with Grafana and Prometheus. And all that is all deployed with Fleet, the automation systems with Rancher. So we can easily take care of our deployments and our technology and leave what is already done, doing faster with the tools already provided by Rancher. And that's some of our tools and operation that we do over there. And every integration, every alert manager, everything that is already integrated, anything that goes wrong, we get an alert throughout Slack or Teams or also Zoom that our organization uses. So we have full control and visibility of any incident that occurs throughout our network. On our string clusters, we have a standardized setup, so everything that is done on development, staging, and reaching production in the internet is always tested and verified in the similar and same way. So we can actually have verifiable loads, verifiable application throughout our development cycle. So we have about 3 worker nodes only set up for Longhorn. So we can actually have high availability and resiliency throughout our data stack and enhancing how we manage that throughout our applications as well. And that gives us a full visibility over the data that we have, over the control nodes that we have as well. Throughout that, we also have SUSE Linux running on all of our servers. Every virtual machine that we own, not all of them are updated, but we actually manage everything with SUSE Manager. We have SUSE Observability, and everything is running throughout SUSE Linux as well. And that gives us full security, keeping everything patched and up to date to any CVEs or any operation that we need to have control throughout our technological part. And moving that to the cloud was seamless because we also have support over there as well. So in the next steps for us, having a hybrid environment, that was a big, big step for us. So let's talk a little about our migration challenges. So when we landed on RKE1, and we had a lot of issues moving forward with infrastructure issues, network issues, and we wanted to, okay, how we going to move forward and how RKE2 will help us throughout that. So we had some major challenges, mostly regarding storage migration. So we processed up like 300 terabytes for those lawsuits, and having that information for multiple applications easily transitioning was something that we had to be mindful about. Another problem that we had with the older version of the Longhorn was also the dynamic volume growth. So some applications were really like writing a lot of data, 1 terabyte, 3 terabytes, 200 terabytes, and sometimes that process go along, move forward, and we delete it. And that volume is not redeemed, so we end up like having many manual actions to grow that volume, treat that volume, and that was not automatic, and that was a lot of pain for our organization having to handle that. And Longhorn was not able to do like these snapshots and having the file system tree well at that time. So storage and data needs to be easily manageable and actually have this on our side with the upgrade was something that we had on our mind all the time. Another challenge that we have was the downtime of our applications. How are we going to manage that? Like for so big environment, we have today over 800 applications running on our systems. Some of them are stateless, some of them are stateful. How we actually manage all this with the downtime, compatibility issues with versions of Kubernetes, versions of Helm, versions of the system that we are going to use. So we need to have all these thoughts before we actually moving forward. And we also need to adjust the pipelines for our CI/CD operations automation, as we had a diverse environment. Some actually just deploy on VMs, or they have AI systems that run on physical machines because of the high load in operation. So we needed to focus on all that throughout one single migration for all the applications. So that was a big, big change for us. And one thing that was critical for us was the deploy that we did in a new environment. We didn't like just migrated the old environment that we have. We actually decided to go for a new one where we wouldn't have like 5-6 years of manual operations to make it work, but we have a new environment with like new firewall rules, understanding everything that should be lifted or blocked. And that will give us a full visibility on what is needed for our system to operate, and it will be a brand new environment and very well established. So that was our challenges and how we actually planned to move it there on. So we set up, we evaluated everything, and we came up with a plan of migration. So we first identified every stateless and stateful application that we had on our systems. We planned our migration for all of those applications. And we started to adapt and test all these applications on the new cluster already. And that was something that we had already on our architecture, because instead of having multiple applications with multiple deployments, multiple Helm charts, we had like almost 3 or 6 months before that, we already had one single Helm chart, generic enough to handle all of our 800 applications. So instead of having one change for every single application, we have to change only one Helm chart, and that applied to all of our applications in a single step. So that was how we actually managed to do that fast and stable. And also on the CI/CD operation was just one change, one single cluster adding to that deployment. And that was how we actually planned to have that as a better management system for our operations. Using SUSE Manager and Rancher Manager, we actually did that going for all the downstreams. And we use a DNS to just have a blue-green deployment, testing that. And once we did the migration, we had all the workloads already tested on all the new clusters, and it was just like switching off from moving the workloads from the legacy clusters to the new ones. And that's what we did, but what and how we benefited from that. So we actually had a way to easily restore and move the loads with the SUSE Longhorn. So we only simply do the backup, restore in the new cluster, mount the volume, and that's done. We use a tool called kubedump to dump the whole Kubernetes namespace, and we just transition that to the new cluster and spin up the application. So all the data was already there. It took a time to clone the volumes, to clone the data, but we had already set up for that. So it was a seamless transition for all of our applications. So after we did that, the legacy cluster was pulled off. We have everything tested and done in the new cluster, and we were safe and sure that if anything goes wrong, we could easily roll back and let's move forward with a different approach. But we are safe that the new stuff was ready, and if anything goes wrong, we can easily restore the backups and move back through a better stabilization system. And we could easily monitor and have visibility of everything on every way throughout our migration. So just giving a full overview of what we did in terms of Longhorn configuration. At the time, we had NFS for the storage of our backup. So we set up NFS, we just set up the backups to send it there, but you can easily store it on S3, Azure, anything that goes for the cloud. So you can have your own Isilon or NFS or SIF, whatever you need for storage. And once you do that, we have your backup, and we'll just restore it. Once it's healthy and green, you can just bind to our application, spin it up, and it's ready to go. Not much suffering from that. And one benefit that we got from that, it got rid of those trimming and file system growth problems that we had. So the newer version already handles that automatically. So if I write a lot of data and delete it after, I get my space back. So that was very important for us. So let's talk a little about what the results that we achieved. At that time, we only had about 781 applications, stateful and stateless. So we had a minimal downtime. We actually had a schedule for 7 hours of downtime. And for the 7 hours, we actually had 3 of monitoring and less than that of downtime for all the 700 applications. So it was very important for us that this was not impacting the whole country for a long time. And we did it in a very fashion way, and it was really good for our organization. And people was asking like, oh, is it done? Did you cancel it? No, it's already done. People were just like, using just like normally like it was before. And we had a fast migration of all these stateful applications because of this process as well. So it was very good for the visibility of our team and our organization. We had a visualization of all the process throughout Rancher, observability, and also Longhorn visibility for all the volumes that we were using there. And we had the possibility to roll back in case of any disasters. So that's what we did, but that's not the last thing. So we are preparing for things and moving forward to the future. As I said, we are preparing for a hybrid environment. We are already using cloud, AWS. So that's the next steps for us. So moving also to AI applications, SUSE AI is coming through. We already have some AI projects going on. And also we moving to full observability with SUSE. So we have been partners with SUSE for more than 15 years now. And the benefit for this partnership is having confidence of all the products and projects that we're working together are already validated and tested, and we can actually ensure that our organization actions will be benefiting from everything that we've been doing together. Well, thank you everyone. If you have any questions, have a good day.
Thank you.